Welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss a mole of liquid and different questions from different past papers. This is uh, 9701 June 1 2 and question paper 2 1 and question number 2. Ammonium sulfate is widely used as fertilizers in order to determine its percentage purity. So just identify the main focus point, percentage purity you are going to calculate. A sample of ammonium sulfate fertilizers was analyzed by reaction a known amount with an excess of sodium hydroxide and then titrating with sodium hydroxide and HCl. By reacting amount of excess sodium hydroxide and ammonium sulfate reacts with sodium hydroxide in a 1:2. So the question is, the reaction is ammonium sulfate when react with sodium hydroxide. First, sodium hydroxide react with ammonium sulfate, and then because sodium hydroxide is used in excess, so then this solution, this salt which is produced, this is ammonia Na2SO4. You know, in this salt excess ammonia is sodium hydroxide is present, and plus water. Now balance this reaction by 2 NH3 and 2 H2O. Now this solution is treated with HCl further. A 5-gram sample of fertilizers containing ammonium sulfate was warmed with 50 centimeter cube of an excess of 2 mole per dm cube sodium hydroxide. Now 5-gram sample of ammonium sulfate was warmed with 50 centimeter cube of an excess of 2 mole. So sodium hydroxide is using in excess, and when they react with each other, ammonia gas is formed and sodium sulfate containing excess of sodium hydroxide. When all the ammonia had been given off, the solution was cooled. The remaining sodium hydroxide was then titrated with 1 mole per dm cube of HCl, and 31.2 centimeter cube were required. Now sodium hydroxide is titrated with, concentration of HCl is this, and 31.2 centimeter cube of volume of HCl. Write a balanced equation between sodium hydroxide and HCl. Calculate the amount in moles of HCl in 31.2 centimeter cube of 1 mole per dm cube HCl. We know the mole of HCl is equal to concentration into volume in centimeter cube divided by 1000, and concentration unit is mole per dm cube. The mole of HCl is equal to 1 mole into 31.2 divided by 1000. So the answer is 0.03 mole. Now calculate the amount in moles of HCl in 31.2 centimeter cube of. Now find out the mole of sodium hydroxide which is used to react with HCl by using mole ratio. So there is 1:1 and 0.03 moles to form. Cross multiply and moles of sodium hydroxide is equal to 0.03. Calculate the amount in moles of sodium hydroxide in 50 centimeter cube of 2 mole 50 centimeter cube of 2 mole per dm cube of sodium hydroxide. This is actual concentration of sodium hydroxide is used to react with ammonium sulfate. So mole of sodium hydroxide. This is actual mole of sodium hydroxide. This is concentration into volume 50 divided by 1000. The moles are now use your answer 1, 2 and 3 to calculate the amount in moles of sodium hydroxide that actually react with. So to find out we just have 2 mole 0.10. This is actual mole and this is used mole. Now the moles are 0.0688. Now use your answer to 4 and equation in A to calculate the amount in moles of ammonium sulfate that reacted with sodium hydroxide. Now by using mole ratio, ammonium sulfate cross multiply and moles of ammonium sulfate are 0.0 4 to calculate the mass of ammonium sulfate. Mole is equal to mass over mr. Mole are 0.0344 and mass is mr is 132. Now mass is equal to mole into mr. This is equal to 4.5408, that is 4.54. Now calculate percentage purity is equal to 4.5408 5408 divided by 90.816, and the answer is 90.8. So there is another question. Chili salt pepper is bitter is mineral found in Chile and Peru, and which mainly consists of sodium nitrate. Sodium nitrate. The mineral is purified to concentrate the sodium nitrate, which is used as a fertilizer and some fireworks. In order to find the purity of sample of sodium nitrate, the compound is heated in sodium hydroxide with Devret's alloy, which contain aluminum. This reduces the sodium nitrate to ammonia, which is boiled off and then dissolved in acid. So this is the sodium nitrate. This is actually chili salt bitter, and uh, which contains aluminium. This is an alloy and it contains aluminium. It reacts with sodium hydroxide to form ammonia and sodium aluminate. The ammonia gas produced is dissolved in an excess of H2SO4. Now, ammonia gas, which is formed in this reaction, is dissolved in an excess of sulfuric acid of known concentration. The amount of unreacted H2SO4 is then determined by back titration with sodium hydroxide of known concentration. Sulfuric acid plus sodium hydroxide. Again, this sulfuric acid of known excess sulfuric acid. This salt is further treated with sodium hydroxide of known concentration. With this sodium hydroxide. Now this salt, which has excess of H2SO4, is further treated with sodium hydroxide with known concentration. Sulfuric acid, now we mention over here sulfuric acid, not ammonium, because in this salt sulfuric acid is in excess, plus sodium hydroxide forms sodium sulfate plus water. 1.64 gram sample of impure sodium nitrate was reacted with an excess of Devret's alloy. The ammonia produced was dissolved in 25 centimeter cube of ammonia, which is produced in this reaction. Look at this. This reaction ammonia is produced. This react with this sulfuric acid, which is in excess. When all of the ammonia had dissolved, the resulting solution was titrated with sodium hydroxide. Then this solution, which react with ammonia and then react with sodium hydroxide for neutralization. 16.2 centimeter cube of sodium hydroxide. Calculate the amount in moles of sulfuric acid present in the amount in moles of sulfuric acid present in 25 centimeter. So first calculate a mole of sulfuric acid. This is actual amount of sulfuric acid is used. So concentration into volume, and volume in centimeter cube, so divided by 1000 into 25 divided by 1000. This is equal to 0.025 mole. Now calculate the amount in moles of sodium hydroxide present in 16.2. Calculate, this is also actual mole of which is treated with this sulfuric acid. which react with the ammonia and then react with sodium hydroxide. Mole of sodium hydroxide is equal to 16 2 moles concentration 2 mole per dm cube into 16.2 centimeter cube, so divided by 1000 to equalize the unit. This is equal to 0.0324. Now use your answer to 2 to calculate the amount in moles of sulfuric acid that reacted with 16.2 centimeter cube of 2 mole per dm cube of sodium hydroxide. Now this is the answer to calculate the amount in moles of sulfuric acid that reacted with 16.2 moles of, like this. Now check when react with sodium hydroxide, which dissolve with ammonia. This amount is dissolved in ammonia first, then over here excess sulfuric acid is present. Now this amount react with sodium hydroxide, which have mole 16.2 centimeter cube of 2 mole. Now we have calculated the mole of sodium hydroxide for these quantities, and from this quantity which sodium hydroxide which react with sulfuric acid to form salt and water. Now we have to calculate sulfuric acid mole from this molar quantity by using mole ratio. We know that sodium hydroxide react with sulfuric acid 1:2 ratio. H2SO4 ratio sodium hydroxide to 1:2. From the equation we know, from the equation it react with 1:2. So sulfuric acid mole is 0.0324 ratio x. By using cross multiply, the moles are sodium and sulfuric acid mole. No, this mole, sorry, these moles are of sulfuric acid. 0.0324 ratio x. Now sulfuric acid moles are is equal to 0.0162. Now using your answer 1 and 3, this is these moles which is actually used with ammonia. So, and these moles when that amount react with sodium hydroxide. So use your answer 1 and 3 to calculate the amount in moles of sulfuric that reacted with ammonia. So by subtracting these 2 moles of sulfuric acid, 0, this is their actual mole 0.025, and the moles which are reacted with sodium hydroxide, that moles are actually reacted with ammonia. So this is why we know this back titration. So this is this titration is known as back titration. Sulfuric acid is equal to 0.025 minus 0.0162. Why it is known as back titration? Because first of all, look at this. First of all, sodium hydroxide react with this. Now the ammonia which is produced from this reaction dissolve in sulfuric acid, which has this quantity and which is in excess. Now this is in excess. Now the amount unreacted is then determined by back titration with sodium hydroxide. The amount of this compound which has excess of sulfuric acid, so it is further treated with sodium hydroxide. to form sodium sulfate, and now the answer is 0.0088. Use your answer to 4 to calculate the amount in moles of ammonia that reacted with H2SO4. Now by using mole ratio with ammonia and sulfuric acid, H2SO4 2:1, and from the equation we know that the 2 moles of ammonia react with sulfuric acid to form ammonium sulfate. So 2:1, x is equal to 0.0088. The moles are n moles of ammonia. Moles of ammonia is equal to 0.0176. Now use your answer 5 to calculate the amount in moles of sodium nitrate that reacted with the Devreda's alloy. Ammonia ratio sodium nitrate. Now we get moles of ammonia. Now by taking mole ratio of ammonia with sodium nitrate, 3:3, from the chemical equation we know that 3 moles of sodium nitrate, or this alloy, this is an Devreda's alloy, react with sodium hydroxide to produce ammonia. 3 moles with 3 mole of ammonia, and we know that 0.0176 ratio x. The moles are same. Now is equal to 0. By cross multiply 0.0176. Now calculate the mass of sodium nitrate reacted. Mole is equal to mass over into mr, and 0. Mole is equal to mass is equal to mole into mr. 0.0176 into mr is of sodium nitrate is 85. The answer is mass of sodium nitrate is 1.496. So this is the mass of sodium nitrate. Now use your answer 7 to calculate the percentage by mass of sodium nitrate present in the pure sample. We have sample of sodium nitrate is 1.64 gram. This is a sample of sodium nitrate. Now percentage of by mass of sodium nitrate, which is actually react, 1.496 divided by mass of alloy into 100, and this is equal to 91.219. So the answer should be in your answer in suitable significant figures. So this how to identify that how many significant figures are there. So look at the values which are given in the question. So 1.64, and 3 significant figures are there: 16.2, 2.00, 25.0. So the answer should be in 3 significant figures. 91.2 to above reaction is an example of a redox reaction. What are the oxidation number? What are the oxidation number of nitrogen in sodium nitrate and in ammonia? In ammonia it is -3. In sodium nitrate we can calculate sodium 1 nitrogen is equal to 0, x plus 3 minus 2 is equal to 0. 1 plus x minus 6 is equal to 0. X minus 5 is equal to 0. So x is equal to 5. The nitrogen oxidation state is +5.